Welcome to the true part 6 of my low temperature switch. The previous one was part 5, but I did say part 6. Anyway, so the hardest part we have done, that was the power supply board. Now it's much easier. We do the upper board now. The upper board, we just have to connect some terminals, and that's it, basically. We have on the left side the terminals for the measurements, battery in and battery out, solar in and solar out. Then we have 2 little terminals and 3 little terminals here for the little isolation boards. They sit there. I have soldered some pins on it, and then I stick them right on. Then I put a line of terminals here and a line of terminals there. And these 2 lines, they represent all the pins on the Arduino. I put them there to have them all available. And on the other hand, when I'm finished with the whole thing, I don't need this USB connection no more. And that would mean I could just use a smaller version of Arduino and stick this on here, and then I'm done. Okay, that's the other thing we need. We need a little bridge that disconnects the 5-volt power supply from the board if I'm using the regular Arduino, because it gets its 5 volts from the USB cable. But if I use these little ones, I put this little bridge in, so I have my good 5 volt from the power supply board. So then we have the little line of terminals here. They are to connect the power supply board with the upper board. And on this side here, I have this clamp terminals. These are these ones. They're very nice little clamp terminals. I clamp on the 2 temperature sensors, and I clamp on a ground wire and the wire for the IGBT, the gate wire. Okay, that's it. Let's have a look at this board. So they have these pins here. They're sticking in there. That's just it. And we have our two resistors here. By the way, the size of the resistors have changed a little bit. So let's have a look at the drawing of this 2 isolation boards. That would be this drawing here, and we have the input, and we have the output, and we have a power supply. I use the 12 volts from the power supply board, of course. So we see on the input we have this R7 and R9. These big resistors here in the bottom. They get hot because that's why I put them a little distance from the board. Because by 20 milliamps and let's say 80 volts or 100 volts, 20 milliamps and 100 volts, that's quite some power that's getting dissipated here. Okay, these are the 2 resistors. Then I have a capacitor, C12, C14. This capacitor is to smoothen out as a filter capacitor. And I have a Zener diode on the input here, D4 and D6. And if we have a look at the list, D4 and D6, D6 is 2.4 volts. We have measured that by 5 volt output, the input has around 2.5 volts, more or less. So I put a Zener of 2.4 volts here. That means if the voltage here is higher than 2.4 volts, it gets conducted through the diode back and not through the isolator. That means I limit basically the input of the isolator to 2.4 volts. The same I've done on the outside. I have put a resistor and a capacitor that it actually is a low pass filter on one hand, and on the other hand it's a protection for the pins. Then I have added the Zener diode on the outside too, and if you look at the list, this is Zener D5 and D8, and D5 and D8, D5, D8, I have put a 5.6 volt Zener diode. Why not a 5.1 volt? Yeah, I tried it with a 5.1 volt and it was not enough. I needed a higher voltage diode. What is this Zener diode doing? Okay, it protects the Arduino from too high voltage. It makes sure the maximum that's coming out and arriving at the Arduino pin is around 5 volts when there's 2.4 on the input or 20 milliamps or at the input. Now I have another diode in the ground line and on both, and that is kind of an isolation diode. I was not really sure. This isolator, I'm not really sure if it isolates 100% because I couldn't find an analog digital converter and an optocoupler, and therefore I just added in the ground line these two diodes. These are Schottky diodes. So I put all this, and if I pull one out here, pull this out, then you see I put these parts all under it here, and they sit here, and this little part here is Schottky diode, is a double Schottky diode. I had it in stock, so I used it, and okay, so far so good. So then I have taken this board and I put it on this board here. It's like this. Then I put some power on it. I don't remember what power, doesn't matter. We have our regulation here. So the power I needed to provide the right power supply for these isolation boards. Then I used a special power supply and I put between 0 and 80 volts, I think, on this on this wire here. And then I measured the voltage on the output to ground, and I measured that every 1 volt step. I think I'm not sure every 5 volt step. I have to look for that graph where it is. I'm not sure where it is. Let's have a break here. I have to have a look for the right paper first. So I have the paper here, and what we can see that this is with a 5.6 volts, and we see at around 80 volts, up to 80 volts, this is exactly straight here, more or less. And this is what I wanted to have. With a 5.1 Zener diode, it started to reduce the voltage too early. I programmed now the Arduino to have a voltage range to 80 volts, and that is actually the range I'm using. Everything else above it is from the Arduino interpreted as 80 volts. And then I get this curve, and so I know exactly which voltage is related to which output. All right. Okay, that was that so far, and the last thing. This is a short movie because, how I said, the hardest is done already. Let's talk about the wiring under it. I didn't talk about that, and we see that here. So we have from the power supply board. This is the the connector from the power supply board, and we have here several things coming in. For us right now relevant is plus 5 volt ground, plus 12 volt, and this is coming in here. We later make the connections for the cooling fan. It's regulated by the Arduino as well, and of course for the sensors and so on. They are not in that drawing right now. I put them maybe on another drawing. I'm not sure, just to make it a little bit more nice. So we have the 5 volt connection bridge here. If we use the external Arduino, we have the ground connection to the Arduino here. We have pin 2 and 3 here. We use them probably later. We have the ground here going, and we have the 12 volt here going. And on this side we have the analog input 1 and the analog input 2, A0 and A1, they are named, and the 5 volt here. So at the end we stick that in here on that piece, and we are in business. From the 12 volt we power supply the tiny isolator boards. Then we have here the resistor capacitor, the same here, capacitor, resistor, capacitor to ground. Here I have the Zener, the capacitor and the resistor, and I have the other output here, and I have the resistor, the capacitor and the Zener, and here I have this Schottky diodes. They make sure that the negative, the ground from the flows only in one direction, so gives us another isolation. On the incoming side is the same. I have the resistor and the capacitor, resistor and the capacitor and the Zener, and then goes on the input. That's basically it, done. Okay, so that was it for today. What's coming now is the wiring for the fan and the wiring for the sensors and the IGBT, and then we can make our first test. So part 7 will be probably the last building part, and part 8 will be the final test of it. Have a nice day and see you later. Bye.